OCR GCSE Computer Science, Episode 9, Binary Numbers. Hi everyone, welcome to Noel for GCSE, and in this video you'll be learning about how to write in binary, how to convert between binary and denary, how to add binary numbers, the overflow error, with lots of exam questions embedded throughout the video. But let's begin with a bit of a recap from episode 8. So we learned about the differences between binary and denary, binary being base 2, so the values double, and denary being base 10, so each time the value moves up by a multiple of 10. We also looked at the different units from a single bit all the way up till a petabyte. Now, counting in binary is very similar to counting in denary, but the place values from right to left increase by powers of 2. For example, 1, 2, 4, 8, instead of powers of 10, like denary, which goes 1, 10, 100, 1,000, etc. Let's look at how this system works. When computer scientists write like this, 0011, 0101, this is what each value truly stands for. So you've got the base 2 going from right to left, so the 1 at the end stands for 1. The 0 then means that there's no 2s. The 1 then stands for a 4. The 0 means there's no 8s. The 1 stands for a 16. The 1 stands for a 32. The 0 stands for no 64s and no 128s. So the 1s represent the respective denary value, and the 0s represents an absence of that value. So this number is equal to 32 plus 16 plus 4 plus 1, which is 66. Now, pause the video here to try this exam question yourself. An alarm clock is controlled by a microprocessor. It uses a 24-hour clock. The hour is represented by an 8-bit register A, and the number of minutes is represented by another 8-bit register B. Identify what time is represented by the following 2-bit 8 registers. And also work out number B, which is that an alarm has been set for 7:30. Two 8-bit registers, C and D, are used to represent the hours and minutes. Show how 7:30 will be represented. Okay, let's look at the answers now. So, the hours is 18 and the minutes is 53, so it's 18:53 or 6:53. And to show 7:30, you would show register C showing the number 7 and register D showing the number 30 in binary values. Okay, now adding binary numbers with column addition. So there's a couple of binary addition rules that you need to know. Some of them are straightforward. For example, a 0 plus a 0 is 0. A 0 plus a 1 is 1. And a 1 plus a 0 is 1. But it changes a little bit. When you have a 1 plus a 1, instead of getting 2, you would get a 0 and carry over that 1. Now, if you don't understand what carrying over is, we are going to look at that in a second. Now, if you have 1 plus 1 plus 1, you don't get 3 like denary. What you do is your result is 1 and you carry over a 1. So remember to try and memorize these 5 different rules, and let's look at the example now. So let's look at this example. You've got 1, 2, 3, 4, 5-digit binary numbers. We're adding together 5 and 5. So the first, you always start from right-hand side to left-hand side. So we are doing 1 plus 0. Now remember, a 1 plus a 0 is the same as in denary. It's just 1. Then you move on to the next one. So 0 plus 0, which is just 0. Again, the same in denary. But then you have a 1 plus a 1. So when you have 1 plus 1, in denary we know that 1 plus 1 is 2. And 2 is represented in binary as 1, 0. And that's why you put the 0 there and carry over a 1. Now, for your next one, you have 1 from the carried over plus 0 plus 1. So again, you have 1 plus 1, which we know is 2. So 2 in binary is 1, 0. So you put a 0 in the placeholder and carry over the 1 again. In your final column, you have 3 ones. Now remember, 1 plus 1 plus 1 is 3, and in terms of that being referenced in binary, 3 is referenced as the number 1, 1, so your answer should be 1, 1. So, let's look at what this new digit means, however, because remember, we added 2 5-digit numbers, and we've somehow ended up with a 6-digit number. So what does this mean? Now, this is something called the overflow error. This is whenever you get a binary value that requires more bits than the CPU is expecting. So, for example, in this question you can see here, we've added up two 8-bit binary numbers, which both stand for a byte. And let's say the CPU only allows 1 byte of a response. However, when you add them, you actually get 1 byte plus an extra bit. So computers usually deal with these extra bits by storing them elsewhere. But you would always have to mention in the computing exam that it's called an overflow error. Now let's look at some exam question practice. So convert the denary number 107 to binary, and B, represent the denary number 300 as it would be stored in a 12-bit binary register. So that's a bit of a challenging one. So pause the video and have a go. Let's look at the answers now. So the denary number, or 107 to binary, would be 0110111, and representing the denary number 300 as a 12-bit binary register, then that means that you have to have your normal 8 bits and then add an extra amount, and you can see the mark distribution there. Now, thank you so much for watching this video. If you found this video beneficial or helpful to you, feel free to subscribe if you haven't already to Knowledgeable GCSE and Knowledgeable A-Level. Thank you so much for your watching and your support. It's really lovely to see so many students so grateful and sharing in the comments. Now, have a really nice day and see you soon.